So you've seen that sum up top. 1 plus 2 plus 3 up to n is n times n plus 1 over 2. In this video, we're going to find the sum of squares formula. 1 squared plus 2 squared plus 3 squared all the way up to n squared, a general formula for it using a method that you've not seen before that also applies to the top sum. If you have seen it before, drop a comment down below. And don't worry if you don't know how to do the top sum, I've got you covered. There's a video, links in the description down below on my channel, explaining how to find that sum and also explaining what a variable is. It is introductory math that anyone can understand. But here we're going to find out this sum now. And we're going to start off by finding the top sum using that new method that I didn't use in that video, but it's going to be motivated to allow us to find the sum of squares. So let's dive into that. So the first thing is to do the following seemingly deceptive trick. So I'm going to take n plus 1 squared minus n squared, and I'm going to add on n squared minus n minus 1 squared. And I'm going to keep going. I'm going to take differences of successive squares, and I'm going to keep going all the way up to 2 squared minus 1 squared plus 1 squared. Okay, that's what I'm going to do. Now, this is what we call in math a telescoping sum. It's telescoping because there is cancellation. N squared cancels with n squared. N minus 1 squared is going to cancel with the next term. And so on. 2 squared is going to cancel with 2 squared. Minus 1 squared is going to cancel with 1 squared. Okay, so negative and positive signs are alternating. And what we're actually going to get is just n plus 1 squared. However, there's another way of calculating this sum. And in math, when you want to show two things are equal, a common trick is to find them out in different ways. Add up things in two different ways. So here, instead of doing this cancellation, which is kind of dumb in some sense, let's start off by finding each of the brackets, what's happening. Okay, so if we look at the first brackets, I'm going to use, you can use the binomial theorem. I've got a video on that in my channel. Check it out. Links in the description down below. But what we can do is, in general, if we have some expression like I plus 1 squared minus I squared, how are we going to figure this out? So you can use the binomial theorem, you can use the difference of squares formula. So I'm just going to use the difference of squares formula here. A squared minus b squared is a minus b times a plus b. So a squared minus b squared is going to equal to a minus b times a plus b. And what we can do is we can write that up top. So we're going to get I plus 1 minus I, which is just 1, because they are successive integers. And so we're going to get 1 times I plus 1 plus I, okay, which is going to be 2i plus 1. So now notice that if we think about what the i's are in each case, when we start off with 2 squared minus 1 squared, if we want to compare that to I plus 1 squared minus I squared, I better be 1, right? So here this is like I is 1. Here this is like I is n minus 1. You have I plus 1 squared minus I squared. And here it's like I is n. Okay, so we're adding up these expressions, which are just going to be 2i plus 1. Because 2i plus 1 times 1 is just 2i plus 1. We're adding it up from 1 to n. Okay, so let's kind of do that. So we've got the 2i plus 1, so I'm just going to erase that. And what we can do is we can just say that the sum is going to be, we've got the stray 1 there, so we have to keep that in mind. So we're going to get sum I equals 1 to n of 2i plus 1. Okay, all this notation means is, it's just introducing this notation. So don't be intimidated by it if you haven't seen it. It's just 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1. You're just adding up this expression as I goes from 1 to n. So you're adding up n of these expressions. And then what we're going to get is we're going to add on 1, and that's going to equal to n plus 1 squared. And now we're almost done with the top sum that we wanted to figure out the formula for, because we can solve for what the sum I equals 1 to n of I is. Okay, so this is just going to equal to 2 times the sum I equals 1 to n of I plus sum I equals 1 to n of 1 plus 1. That's going to equal to n plus 1 squared. And now you see here that the sum I equals 1 to n of 1 is just adding 1 n times with itself is just n. Okay, so you get n plus 1 here. Okay, so I'm going to write that down. You're just going to get n plus 1 here. And then you're going to get, you take off the n plus 1 to the other side. So you subtract both sides. You subtract n plus 1. And you're going to get that 2 times the sum as I varies from 1 to n of I is just going to equal to n plus 1 squared minus n plus 1. Okay, so n plus 1 squared minus n plus 1. So of course you can factor out an n plus 1 from that. So you're just going to get n plus 1 times n plus 1 minus 1. Okay, which is just n. So it's n plus 1 times n, and then that's therefore going to imply, once you divide by 2 on top and on both sides, you're going to get sum I equals 1 to n of I, which is just 1 plus 2 plus 3 plus 4 all the way up to n. It's just going to equal to n times n plus 1 divided by 2. So that's going to be the formula for this 1 plus 2 plus 3 up to n, and it's done by this telescoping sum trick that's going to apply to now find out the next step. So let's do that. So this is kind of the motivation, and now we're going to find out the sum of n, 1 squared plus 2 squared all the way up to n squared. And this video is self-contained because I actually gave you the way of finding the sum 1, 2 up to n, but of course it's a trick, and in the video I have on my channel I've kind of explained another more famous way of finding that sum, which is another trick, but it's a little bit more intuitive than this one. Okay, so now that we've done that, we're going to now get up to the next sum, which is summing up 1 squared plus 2 squared all the way up to n squared. Okay, so here's what we're going to do. We're going to start off with a similar idea. We're going to start off, instead of the same thing we did just now, we're going to do with cubes. Okay, so we're going to start off by saying n plus 1 cubed minus n cubed plus n cubed minus n minus 1 cubed. Okay, so you're taking successive differences of cubes going all the way up to 2 cubed minus 1 cubed plus 1 cubed. Okay, so now again this is a telescoping sum. Okay, so it's telescoping. You can cancel the negative n cubed with an n cubed, the negative n minus 1 cubed with the positive n minus 1 cubed. There'll be a negative 2 cubed with a 2 cubed and a negative 1 cubed with a 1 cubed. So if you actually wanted to work this out, you know this is equal to n plus 1 cubed. But as in math, if we find another way of summing this, you're going to get an interesting equation. So that's always a strategy. If you want to prove interesting identities, you can just play around, finding different ways of adding two things up. You can come up with some cool expressions that are equal that look really amazing, and people will wonder, how do you do it? So that's like kind of one of the things. But of course, to find out a particular sum, you have to be a bit more creative with that. So here we're going to find out how to do this expression in the same way. So I'm going to do the same thing as before. I'm going to take I plus 1 cubed minus I cubed. Okay, so what is the difference of two successive cubes? So we can use either the generalized binomial theorem or the difference of cubes formula. So I have a video on my channel, it's quite popular, check it out, how to think about the difference of cubes formula. The difference of cubes formula says that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. This is super fundamental in high school and college math, so I'm just showing this to you, and we'll do it this way to find out this difference. So here we're going to get, using that difference of cubes formula, we're just going to get I plus 1 minus I, the a minus b, which is just 1 because they're successive integers, times a squared plus ab plus b squared. Okay, so a squared is going to be I plus 1 squared, plus ab, which is I plus 1 times I, plus b squared, which is just going to be I squared. Okay, so we get this. And we can now work this out. We can collect terms, so we can use the binomial theorem. I've got a video on my channel on that, as Isaac Newton did it. So I plus 1 squared using geometry, thinking about it geometrically. If you haven't seen that, check it out. I squared plus 2i plus 1 plus I squared plus I squared, which is just going to equal to, you've got 3i squareds, and you've got 2i plus I, which is 3i, and you've got a 1. Okay, so you're going to get 3i squared plus 3i plus 1. So that's going to be, each of the terms in brackets in this expression is going to be of this form, 3i squared plus 3i plus 1. And if we kind of think about it, I plus 1 cubed minus I cubed, well, here I is 1. It's got 1 plus 1 cubed, which is 2 cubed minus 1 cubed. Here you've got I is n minus 1. You've got n cubed minus n minus 1 cubed. And here you've got I is n. Okay, so that's going to be n plus 1 cubed minus n cubed. So we're looking at a sum as I varies from 1 through n of this expression. And now we're going to solve for the sum of the squares. And, it's worth kind of pausing the video and doing it for yourself, because that gives you the most satisfaction. 3i squared plus 3i plus 1. Okay, so that's what we have to remember. 3i squared plus 3i plus 1, how are we going to add that up? So here, we can just work that out. We've got the stray 1 cubed, which doesn't get included in the sum, so we have to be aware of that. So it's sum I equals 1 to n of 3i squared plus 3i plus 1 plus 1 cubed. Okay, so that's going to equal to n plus 1 cubed. And now that you've done that, we can now solve for the sum of the squares. Okay, that's what we want. Okay, so this is kind of the magic here. We can solve for what the sum I varies from 1 to n of I squared is. So here we're going to get that 3 times sum I equals 1 to n of I squared plus 3 times sum I equals 1 to n of I plus, okay, so this is plus of I, plus sum I equals 1 to n of 1 plus 1 is just going to equal to n plus 1 cubed. Okay, so that's going to be the expression, and now we can put the things we know to the other side. Okay, so here we know that this sum is going to be 3 times n plus 1 by 2. That's what we figured out at the beginning of this video, and also we worked out in this video itself, plus n plus 1. That's going to equal to n plus 1 cubed, so we can put that all on the other side. So I'm just going to erase the top now that we've kind of gotten this far. We know that's going to equal to n plus 1 cubed. Okay, so let me erase the difference of cubes formula, and now it's going to be super cool. We're going to get this beautiful formula that we can now solve for the sum I equals 1 to n of I squared. So it's going to be 3 times sum I equals 1 to n of I squared is going to equal to, so put that on the other side, it's going to be n plus 1 cubed minus of 3 times n plus 1 by 2, 3 times n plus 1 by 2, minus n minus 1. Okay, so minus n minus 1, so minus of n plus 1. And I'm going to actually make a common denominator there. Okay, just say it's minus 2n plus 1 over 2. And now with that common denominator, we can actually simplify this whole thing out. Okay, so we're going to do that. So we're going to now put a common denominator here too. So this is going to be over 2. And now we're going to therefore get, so now I'll erase this. We're going to be able to now factorize the top and get this beautiful formula. And then we're going to finish it off. So let's do that. So here we're going to get 2 times n plus 1 cubed. Okay, so 2 times n plus 1 cubed, and this is a trick, so watch for just clever factoring. You know, rather than expanding everything out, we can directly factor. So here it's going to be minus 3n times n plus 1 minus 2 times n plus 1. So you factor out the n plus 1. So you get minus of 3n plus 2 times n plus 1. Okay, so this is all divided by 2. And now you can actually factor out another n plus 1 here. Okay, so you're going to get 2 times, okay, so maybe I'll factor out an n plus 1. So it's going to be n plus 1 times 2 times n plus 1 squared minus 3n plus 2. Okay, so minus 3n plus 2, all divided by 2. And now you can actually solve for what this expression in parentheses is. So this is going to be, you know, using the binomial, if you like, using the binomial theorem, you can say that that's going to be n plus 1 times 2n plus 1 squared. You know, it's going to be 2n squared plus 4n plus 2 minus 3n minus 2. And that's all divided by 2. And now you can see the factoring is going to come out pretty nice because you can cancel off this, you get a plus n, and the 2 and minus 2 cancel off. So you're going to get 2n squared plus n divided by 2. Okay, so 2n squared plus n, you can factor out a n, and you get 2n plus 1. Okay, so this is going to equal to n plus 1 times 2n plus 1 times n divided by 2. And now, if you want to actually work out what the actual sum is going to be, you just have to divide both sides by 3. So you're then going to get that therefore, so I'm going to put the magic formula on this side of the board. Therefore, the sum I equals 1 to n of I squared, this is the formula we wanted, is going to equal to n times n plus 1 times 2n plus 1, all divided by 6. Okay, so that's going to be the expression, and you kind of expect, okay, so it's going to be a cubic now instead of a quadratic. So you're adding squares, you're going to get a cubic, and that's the formula. So now my challenge to you is find the sum of cubes. Find out what is 1 cubed plus 2 cubed all the way up to n cubed, and drop a comment down below once you've done that. Okay, I want to see like as many people as possible doing that. Leave a like, you know, once you've done that, and if you enjoyed the video. I hope you loved that video. I've got lots of videos on my channel. Try to make math fun, accessible, elite, free, accessible math education at all levels of math. Fun math like this, high school math, college math. You know, if you're in high school and you're trying to learn more advanced math, there's lots of math for you on my channel, and also proof-based maths, thinking about advanced math. I'm a research mathematician. I think about solving problems that haven't been solved for a long time, and I'm trying to deliver math as a journey rather than as an expression of concepts, because it is a creative journey. Thank you so much for watching. I wish you all the best, and I'll see you in the next video.